today I will be discussing the Module 11 for the Quarter 4 or the identifying the appropriate rejection region involving the population proportion. So in this field of statistics, our researchers often encounter the challenges of making inferences about the population proportions based on the sample data. One crucial step in this process is determining whether the observed sample proportion is significantly different from the hypothesized population proportion. This is where the concept of rejection regions comes into play. A rejection region, also known as the critical region, is a range of values that, if the sample proportion falls within it, it leads to the rejection of the hypothesis. The null hypothesis represents the assumption that there is no significant difference between the sample proportion and the hypothesized population proportion. Identifying an appropriate rejection region involves carefully selecting the level of significance, which determines the probability of making an error or rejecting the null hypothesis when it is actually true. By setting a specific level of significance, researchers can control the risk of incorrectly rejecting the null hypothesis. In the context of population proportions, the appropriate rejection region is determined by the desired level of significance, the sample size, and the hypothesized population proportion. By understanding how to construct and interpret rejection regions, researchers can make informed decisions about the significance of their findings. Today, or in this discussion, we will explore the various methods and techniques for identifying an appropriate rejection region involving the population proportions. We will delve into the importance of sample size, the calculation of the test statistics, and the interpretation of results. By mastering these concepts, we will gain a valuable tool for drawing meaningful conclusions from our data. Students to get their module of the Quarter 4 Module 11 and to read with us to read together with us while discussing this. So first, go to page 7 of your module and look for the critical value or the C table. It's here. So first, the critical value separates the rejection region from the acceptance region. It also derived from the level of significance and expressed as the standard C values. Critical value also symbolized as the Z top. So we can use these critical values for the commonly used levels of significance presented in the previous
test type. Left tail test. Level of significance negative 2.33, negative 1.96, negative 1.645, and negative 1.28. Right tail test. Level of significance 2.33, 1.96, 1.645, and 1.28. Two tail test. Positive negative 2.575, positive negative 2.33, positive negative 1.96, and positive negative 1.645. Level of significance. Alpha. Refer to the degree of significance in which we reject or do not reject the null hypothesis. The basis for the critical or the rejection region dictated by the alternative hypothesis. Common value of statistical significance 0.01, highly significant 0.05, statistically significant 0.10, significant. For the instant, if we use 0.5 level of significance, then the size of the rejection region is 0.05 or 5%. For a 0.1, then the size of the rejection region is 1% and 10% for 0.10. Rejection region. The range of the values of the test value which indicates that there is a significant difference and that the null hypothesis should be rejected. Non-rejected region. The range of the values of test value which indicates that the difference was statistically insignificant and that we failed to reject the null hypothesis.
So this is the example number 1. A sample of 100 students is randomly selected from Pinagpala High School, and 18 of them said they are left-handed. Test the hypothesis that less than 20% of the students are left-handed by using A equals 0.5 as the level of significance. So these are the steps you need to follow. So this is the example number 1. First, you need to identify the level of significance. So in the given, the level of significance is 0.05. 0.05. Second, you need to formulate the alternative hypothesis. P. So in the given, it says that the test hypothesis that less than 20%. So this is less than, and the 20% is gagawin nyo siyang decimal. Magiging 0.20. So, ang alternative hypothesis natin ay H sub A, P less than 0.20. The third step is, you need to determine the critical value on the C-table. Makikita nyo yung critical value sa C-table. We consider the intersection of the row for the left-tailed test and the column for 0.05. Hence, the table tells us that the critical value is negative 1.645. Ang ating critical value daw ay negative 1.645. Last step is illustrate the rejection region in the normal curve. You need to illustrate the rejection region in the normal curve. So, dito natin siya i-plot. Ang ating critical value ay negative 1.645. So, dito natin siya ilalagay. Negative 1.645. So, this is the rejection region. Ang ipa-plot natin ay yung critical value. Example number 2. The claim is made that 40% of tax filers use computer software to file their taxes. In a sample of 50 tax filers, 14 use computer software to file their taxes. If H sub A, P less than 0.40 at A equals 0.025, where P is the population proportion who use computer software to file their taxes. Determine the critical value and illustrate the rejection region in the normal curve. So, this is the example number 2. Given na yung level of significance, ang level of significance natin ay 0.025. Given na rin yung alternative hypothesis natin, which is H sub A, P less than 0.40. Ginawa lang din yung 40% na decimal. Ang hahanapin na lang natin ay critical value At i-illustrate natin yung rejection region sa normal curve. Makikita natin ang ating critical value sa C-table. So, ang ating level of significance ay 0.025 at ang nasa given ay less than, which is left-tailed test. So, ang ating magiging critical value ay negative 1.96. We need to illustrate the rejection region in the normal curve. Ang ating critical value ay negative 1.96. So, dito natin siya ipa-plot. Negative 1.96. 1.96. So, ito ang ating rejection region.